2 దశాబ్దాలుగా తెలంగాణ ఆంధ్రప్రదేశ్లో కాంపిటీటివ్ రంగంలో తిరుగులేని సంస్థ
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్.
తెలంగాణ గురుకుల టీచర్స్,
జేఎల్స్, డిఎల్స్,
టీజీటీ, పీజీటీ,
పీఈటీ, పీడీ,
లైబ్రేరియన్స్ కొరకు
స్టేట్ ర్యాంక్స్ తో పాటు వేల సంఖ్యలో అభ్యర్థులను ఉపాధ్యాయులుగా తీర్చిదిద్దిన
డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో
స్టేట్ ఫేమ్ ఫ్యాకల్టీస్ చే ఆన్లైన్ అండ్ ఆఫ్లైన్ బోధన అందించే ఏకైక సంస్థ
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్, దిల్సుఖ్నగర్, హైదరాబాద్.
100% నూతన సిలబస్ ఆధారంగా ఆఫ్లైన్ అండ్ ఆన్లైన్లలో బోధన.
ఆన్లైన్ కోచింగ్ కొరకు డౌన్లోడ్ చేయండి
రామయ్య కాంపిటీటివ్ కోచింగ్ సెంటర్ మొబైల్ యాప్,
ప్లే స్టోర్ అండ్ యాప్ స్టోర్లలో లభ్యం.
ఆన్లైన్ కోచింగ్ లో అన్ని కోర్సులు తక్కువ ఫీజుతో 1 ఇయర్ వ్యాలిడిటీతో పాటు 1 మంత్, 3 మంత్స్, 6 మంత్స్, 9 మంత్స్ వ్యాలిడిటీ ప్యాకేజీలు అందుబాటులో కలవు.
పూర్తి వివరాలకు సంప్రదించండి
9246208422 88855555202.
So today topic is scalars and vectors. So generally we know there will be physical quantities. So what are the physical quantities? We can say the measurable quantities, we can say physical quantities. Example you can write here: length, mass, time, velocity, acceleration, force, density. So dash dash dash. These all we can say these are the physical quantities. These are the measurable quantities. These physical quantities based on magnitude and direction. Based on magnitude and direction. So magnitude and direction. Based on magnitude and direction. The physical quantities can be classified into 2 types. One, it is scalars. Second, it is vectors. Second, it is vectors. So what is a scalar? What is a vector? For example, AB is equal 5 centimeters. AB is equal 5 centimeters. Means A to B length is equal 5 centimeters. Here the 5 centimeter is magnitude. 5 centimeter is magnitude. Suppose a person is moving along east direction. Is moving along east direction. So 5 centimeter towards east. Here 5 centimeter is magnitude, towards east it is a direction. So anything like this you can say here. Here this is a scalars. It has only magnitudes. It has only magnitude, it has no direction. The physical quantities which have only magnitudes are called scalars. So scalar we can say that one here, the physical quantities which have only magnitude, only magnitude are called scalars. Okay. Example you can say this is example: distance, speed, work, energy, power. So these physical quantities dash dash dash. You can say these are the scalars. It has only magnitude. These quantities you can say scalars. Vectors means here it must have that is a magnitude and direction and obey law of vector addition. Law of vector addition. So that type of quantities we can say vectors. So what are the vectors? It is the physical quantities which have both magnitude and direction and obeys laws of vector addition are called vectors. Example, you can say, what are the examples of the vectors? We can say here velocity, displacement, force, momentum. So like this we can say, torque, like this we can say here. These we can say these are the vectors. Anyway, that is all the physical quantities can be classified into two types. One is a scalar, second is a vectors. The physical quantities which has only magnitude, we can say that are the scalars. Example, distance, speed, work, energy and power dash dash dash. And the physical quantities which have both magnitude and direction, that type of quantities we can say that are the vectors, and the vector must obey, that is a law of vector addition. So this we can say example, that is a velocity and displacement, force, momentum, like this we can say. These are the basic introduction about that is a scalars and that is a vectors. Next. Here see representation of vector. Representation of vector. So normally the vector, it is denoted by symbol like this. This is a vector indication, arrow mark, nothing but it is a arrow mark. So in this arrow mark, this ending point we can say this is terminal point. This we can say it is a terminal point. This also we can say it is a head. Also we can say it is a final point. Final point, this we can say here. Terminal point, head or final point we can say. The starting, this we can say this is origin, tail, initial point. Initial point we can say. So the arrow mark we can indicate the symbol like this, and terminal point, head or final point, the ending point we can say. The starting point we can say origin, tail, or that also we can say that is a final point we can say. This is a representation of vector. Length, this indicates that is a magnitude. So this indicates that is a magnitude, whatever it may be. This is direction, this is the length indicated is a magnitude. So this we can say that is a representation of vector we can write. So here this is this is a vector, it is a bar. This is a one more vector, it is a b bar. A bar is equal 10 meters and b bar is equal 10 meters. It is a given like this here. Here A bar it is a right side, b bar also will be right side, and A bar magnitude it is a 10 meter, b bar magnitude it is a 10 meter. Then we can say this is A bar is equal to b bar. These two are the equal vectors, and these two we can say that is a equal vectors. So what are the equal vectors is this vector magnitude same, direction same. That type of vectors we can say equal vectors. So the two vectors which has same magnitude, and direction are called equal vectors. Any vector that is it must have that is a magnitude same, direction also will be same. That type of vectors we can say equal vectors. Second, suppose here this is a vector, it is a bar is equal 10 meters, and this is a one more vector, it is a b bar. This also will be that is a 10 meter. Here first vector, second vector magnitude is same, but A vector right side, B vector left side is there here. This we can say this is negative vector. This we can say that is a negative vector, and the means we can write here A bar is equal minus B bar, we can say A bar is equal minus B bar. So this we can say this is negative vector. Negative vector. This also we can say this is a anti-parallel vector, also we can say anti-parallel. So negative vector also we can say that is a anti-parallel vector. This is a equal vector. This also we can say that is a one more name, that is a parallel vector. It is a parallel vector. This we can say parallel vector. This is a anti-parallel vector. So what is a anti-parallel vector? Is a the vector which has same in magnitude but opposite in direction, is called negative vector, So this is a one more one. Two vector, magnitude same, direction same, we can say equal vectors, or parallel vectors we can say. The vector which has same in magnitude but opposite in direction, we can say that is a negative vector. Next, unit vector. Next it is a unit vector. So normally any vector which has one magnitude or unit magnitude, we can say that is a unit vector. So what is a unit vector? Is a vector which has one magnitude, is called unit vector, Any vector which has one magnitude or unit magnitude is called that is a unit vector. So here that is a unit vector is denoted by symbol like this cap. Unit vector is denoted by symbol. So this we can read, it is a cap. Here this is, if you write here, that is a cap. A cap means it is a unit vector. A cap is equal, we should write that is A bar by modulus of A bar. A cap is equal, we should write that is A bar by modulus of A bar. This also we can write this one, A cap is equal A bar by modulus of A bar, also we can write that is A. So this is a formula for that is a unit vector. What is a unit vector here? The vector which has unit magnitude is called unit vector. It is denoted by symbol that is a cap. A cap is equal A bar by modulus of A bar. Also we can write here A bar by A also we can write. So you try to understand here. Suppose if you write here, this is a bar, it is a vector. If you write here this is a cap, it is a unit vector. If you write this modulus, or also you can write here, if you write here simple without any line like this here, this we can say magnitude of the vector. If you write here straight line, it is a vector. If you write here cap, it is a unit vector. In between the modulus or that is a simple, nothing any bar. If you write like this here, this we can say that is a magnitude of the vector we can write. So here see unit vector, normally 1D, 2D, 3D, 1 dimension, 2 dimension, 3 dimension. 1 dimension means that is only along straight path, it is a linear. 2 dimension means it is a plane and x and y will be there. And 3D means that is a 3 dimension, it is a x, y, z, space. Space means 3D, x axis, y axis, z axis we have to explain. In plane means that is a 2D, x and y only we should explain. And linear means only straight line, either x direction, either y direction, or that is a z direction. So whatever it may be, if you consider that is a space, it is a x axis, it is a y axis, it is a z axis. This is x axis, it is a y axis, it is a z axis. Remember, along x direction always I cap will be there, and I cap it is a unit vector always along that is a x axis. Along y axis always it is a j cap. J cap it is a unit vector along that is a y axis. Along z axis the unit vector it is a k cap. Here means I cap comma j cap comma k cap are unit vectors along x direction, along y direction and along z direction will be there here. So here in this case, for example, this is a origin, this is a origin, that means O. This is a vector, this is a vector A. Means what we can write here, this is a O A bar, it is a vector, O A bar it is a vector. This how can denote this O A bar vector is a, first of all this is a along x axis. Along x axis it is x I cap plus along y axis y j cap, along z axis z k cap, z k cap. So we should write like this, and if it is a vector O A bar we should write like this here, x I cap plus y j cap plus z k cap we get. Suppose here if you write here, this is a point, it is a 2, it is a point, it is a 3, it is a point, it is a 4, if it is a given like this here. And this is a point A indicates with respect to x axis 2, with respect to y axis it is a 3, with respect to z axis it is a 4, if it is a like this here. Then this O A bar is equal, we can write here 2y cap plus 2j cap plus 3k cap. O A bar is equal to, we can write here 2y cap plus 2j cap plus 3k cap we can write it. So this is a vector, the magnitude of the vector means that is a O A bar, means that is a modulus of O A bar is equal, we should write here under root I coefficient how much here 2, it is a 2 square plus j coefficient how much here, that is j coefficient is a 3, 2i plus 3j plus that is a 4k. O A bar is equal with respect to x axis 2 got 2i plus 3j plus that is a 4k. I coefficient 2 2 square plus j coefficient 3 it is a 3 square plus k coefficient 4 it is a 4 square. Magnitude of the vector we can find by this way. Here this is equal to what we can write here, under root 2 square it is a 4 plus it is a 9 plus it is a 16. 16 9 25 plus 4 29 root 29. So this is a magnitude of this vector. Anyway, from this what we have to understand here, I cap comma j cap comma k cap are 3 unit vectors along x comma y comma z axis. So then the vector we can indicate the like this here, the magnitude we can write like this here. To find that is a magnitude, under root I coefficient square plus j coefficient square plus k coefficient square. So under root I coefficient square plus j coefficient square plus k coefficient square, this we can say magnitude of vector we can say here. So this we can say this is a unit vector, means a vector which has one magnitude is called unit vector. Suppose if you write here that is null vector, next one more it is a null vector. Null means it is a 0, and null means it is a 0, a which has 0 magnitude, that's all. A vector which has 0 magnitude, 0 magnitude, a vector which has 0 magnitude is called null vector. A vector which has 1 magnitude is called unit vector, a vector which has 0 magnitude is called null vector we can say here. So in case of the null vector, what is the example here? So for example, a body it is a projected vertically upwards, a body projected vertically upwards here. While moving upwards, the velocity of the body slowly decreases. And that means suppose if we project a body vertically upwards with 10 meter per second, while moving upwards, the speed of the body decreases 10 meter per second, 9 meter per second, 8 meter per second, 7, 6 like this. At particular height, it becomes 0. At particular height, so the final velocity becomes 0. Again, while coming downward direction, highest point the velocity 0, again 1 meter per second, 2 meter per second, 3 meter per second, again that is a 10 meter per second. And that means orally what I want to say here, while the body is moving upwards, the velocity of the body goes to decrease. While coming downward, the velocity of the body goes to increase. So here that is at the highest point, the velocity of the body 0. Velocity is a vector quantity, v is equal 0, magnitude is 0. So we can say that is a null vector example. So what is the example of the null vector? It is a velocity of vertically projected body at maximum height. So velocity of vertically projected body at maximum height. So that is the example for that is a null vector, right? Right. See here I given that is a number 1 equal vectors. Number 2 it is negative vector. Number 3 unit vector. Number 4 null vector. Number 4 it is null vector. Equal vectors means magnitude and direction same. Negative vector means magnitude same and direction opposite. That we can say negative vector. Unit vector means magnitude 1. Is called that is a unit vector. Null vector means that is magnitude 0. Is called that is a null vector. So these are the basic 4 types of the vectors we can say. And coplanar vectors. So this will be different types of vectors. So many are there here. Coplanar means that is a what we can say same plane. The vectors which belongs to same plane, we can say that are the coplanar vectors. Right here this is one more if you want to write here, that is a position vector. If you write here, that is a position vector. What is a position vector? It is a with respect to that is a coordinates. This is a x axis, it is a y axis and it is a z axis. X axis, y axis and z axis. Here for example, this is a body is there here. This is a point is there here. This is a O and this is a point A. O to A I am taking here that is a R bar. The R bar vector it is a position vector and we should indicate that is a what is the position of that is a R bar. So this vector we should indicate with respect to coordinate system. The position of a particle or the position of a body with respect to coordinate system. Is called that is a position vector. So here we can write a position vector, the position of a particle with respect to coordinate system. Is called position vector. Is called, we can say, position vector. So here we can write here this is a R bar is equal x I cap plus y j cap plus z k cap we can write. This is a position vector we can write it. Unit vector, the modulus of vector. Magnitude of the vector, what we can write here, modulus of R bar under root I coefficient square means x square plus j coefficient square means y square plus k coefficient square means that is a z square. This we can write here that is a unit vector r cap is equal, so r bar by modulus of r bar. So this we can write here. This is a r cap is equal r bar by modulus of r bar. So here we can write here that is a r cap is equal, r bar is a this one here. This what we can say that one x I cap plus y j cap plus z k cap we can write. By modulus of r bar is equal this one under root x square plus y square plus we can write here z square. This is to find that is a position vector, unit vector r bar we can write here. R cap is equal we can write here, right. So now I will give that is some numericals how we should find here that is a magnitude of the given vector. First to copy this one, right. See a vector a bar is equal 3i minus 4j plus 2k. 3i minus 4j plus 2k. Find magnitude of vector. Find magnitude of vector. A vector a bar is equal 3i minus 4j plus 2k. Find magnitude of vector. To find the magnitude, it is a nothing. What we have to do? So the magnitude of the vector we can write here in between the two lines, means modulus under root I coefficient square, means 3 square plus j coefficient square. J, it is a minus 4, it is a whole square, plus k coefficient, it is a 2, it is a 2 square we can write. So this we can write here I coefficient square plus j coefficient square plus k coefficient square. This we can write here 9 plus 16 plus 4. It is 29 root 29. So this is a magnitude of the given vector. Any vector. For example, if it is a given like this here, a vector a bar is equal I minus k. Find magnitude. Of the vector. Find magnitude of the vector. Here also it will be same one. So what we can say, that is a, what is a magnitude? A cap is equal the a bar, modulus of a bar is equal I coefficient nothing, means 1 square, plus here j is nothing, and there is no j, not need to write here. K, it is a k coefficient, it is a minus 1 whole square. This what we can write here, 1 square, it is a 1, plus minus 1 whole square, it is a 1. 1 plus 1, it is a root. So the answer, it is a root. A bar is equal I minus k. Magnitude of this vector is equal root 2. Any vector, we should find the magnitude like this here. In the same case here, what is a unit vector at Anand? Unit vector means that is a cap. A cap is equal, what we can say, that one here, a bar by modulus of a bar. A bar already, what is a vector is given, that one. A bar is equal, what we can say here, 3i minus 4j plus 2k. By modulus of a bar is equal magnitude. So this we can write here root 29. So this is a unit vector of the given vector. For this also you can find here. So for this, what we can write here, the unit vector of this one here, a cap is equal a bar by modulus of a bar. So this means what we can write here, a cap is equal, a bar means this one here, what we can say, I minus k by modulus of a bar is a root. It is a root. This is a unit vector, you can say here. It is a unit vector. Right? This is a way to find, that is a magnitude of the given vector. Okay. Copy this.
తెలంగాణ ప్రభుత్వం విడుదల చేసిన 2022 టెట్ ఫలితాలలో రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్ ప్రభంజనం. టెట్ పేపర్ 1లో 133 మార్కులతో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన జె అంజని. టెట్ పేపర్ 2 మ్యాథ్స్ సైన్స్ విభాగంలో 129 మార్కులు, 127 మార్కులతో స్టేట్ టాప్ ర్యాంకులు సాధించిన జె అంజని ఎన్ సరిత. టెట్ పేపర్ 2 సోషల్ స్టడీస్ విభాగంలో 122 మార్కులతో స్టేట్ టాప్ ర్యాంక్ సాధించిన ఏ మమత. మరియు అన్ని పేపర్లలో 90% ఉత్తీర్ణత సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. 2017-18 డిఎస్సి ఎస్జిటిలో స్టేట్ ఫస్ట్ ర్యాంక్ సాధించిన మహేష్. స్టేట్ టాప్ 10 ర్యాంకులతో పాటు అత్యధిక ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. మరియు గురుకుల టీచర్స్ లో టీజీటీ మ్యాథ్స్ స్టేట్ ఫస్ట్ ర్యాంక్ స్రవంతి, టీజీటీ బయో సైన్స్ స్టేట్ ఫస్ట్ ర్యాంక్ సుధా, టీజీటీ సోషల్ స్టేట్ ఫస్ట్ ర్యాంక్ బి శ్రీధర్, టీజీటీ సోషల్ స్టేట్ సెకండ్ ర్యాంక్ రాజేందర్ రెడ్డి, టీజీటీ తెలుగు స్టేట్ ఫస్ట్ ర్యాంక్ అంజన్ కుమార్, ఫిజికల్ డైరెక్టర్ స్టేట్ ఫస్ట్ ర్యాంక్ రాజ్యలక్ష్మి, ఫిజికల్ డైరెక్టర్ స్టేట్ సెకండ్ ర్యాంక్ దివ్య, టీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ శ్రీలక్ష్మి, పీజీటీ ఫిజికల్ సైన్స్ స్టేట్ థర్డ్ ర్యాంక్ మురళి, పీజీటీ ఇంగ్లీష్ స్టేట్ థర్డ్ ర్యాంక్ యాదగిరి. 2017-18 డిఎస్సి గురుకుల టీచర్స్లలో 70 నుండి 80% ఉద్యోగాలు సాధించిన ఏకైక సంస్థ రామయ్య కాంపిటేటివ్ కోచింగ్ సెంటర్. డిఎస్సి గురుకుల టీచర్స్
మరియు గ్రూప్స్ ఎస్ఐ కానిస్టేబుల్స్
కోచింగ్ కొరకు డైరెక్టర్ సిరికొండ లక్ష్మీనారాయణ గారి సారథ్యంలో అత్యుత్తమమైన అధ్యాపక బృందంచే కొత్త బ్యాచ్లు ప్రారంభమైనవి. వివరాలకు సంప్రదించండి 9246208422, 8885555202, 88585900, 8008954440, 8008954448, 8520844463.